Hello everyone, welcome back. In this video, we are going to discuss about the pull-up resistor. Let's start by this case. I have a push button and I have an LED. When I push the push button, the LED turns on, and when I release the push button, the LED turns off. For this to be possible, we have a program. In this program, we have push button connected to pin number 2. We have the LED connected to pin number 3. And we have set the push button as input and the LED as output. To set the push button as input means we are reading the signal from the pin to which the push button is connected. And to set the LED as output means we are sending the signal to the LED, to the pin to which the LED is connected. Still in the setup method, we also initialized the serial monitor to the baud rate of 9600. This is because we needed to print the state of the push button later in the loop method. The program is simple. This is what it will be doing endlessly until you disconnect it from the power or until you flash the microcontroller with the new program. If the push button's state is 0, it means when you press a push button according to this diagram, when you press the push button, this will connect the push button, the pin number 2, directly to the ground. Okay, so in the program, when the push button is connected to the ground, when the signal red is 0, we said we will turn the LED on by sending it the high signal, actually by delivering 5 volts to the LED. Else, that's when the push button is released, the LED will be given 0 volts or low volt. Low means 0 volts. It's low state, not 0. Low volt is low state. Lower state means 0 volt. Okay, so this is how the program operates, and yeah, this is what we are getting when we push the button, and when we push the button, it gets connected to the ground. We read 0, else we read 1 because it's digital. When it's not 0, it's 1. So when it's 1 or just else, that's when we are having it off. Okay, so for this to be possible, our circuit needed a pull-up resistor. Where is the pull-up resistor in this circuit? We have it here. this is where the pull-up resistor is. The pull-up resistor is connected between the digital pin number 2 and 5 volt, because it's pull up. That up means pulling the pin up to the VCC. VCC is known as up, while ground is known as down. VCC is 5 volt, while ground is 0 volt. So pulling up means pulling this pin up to 5 volt or VCC through this resistor. Why do we need this resistor? Because without it, if we didn't have this resistor, if the wire was directly connected from pin number 2 to the VCC, this means when the button is pushed and the pin is also connected to the ground, there will be a short circuit, because there will be the VCC, it means 5 volts, meeting directly the ground here, without passing through any resistor. So this would be the VCC. If this was wired and there was no resistor, this would mean pressing this push button means the current is directly leaving the VCC and going directly to the ground, and this is known as short circuit. It's dangerous. That's why we need a resistor in between, and that resistor is known as pull-up resistor. Its value, well, I have a 10 kilo ohm here. It's a resistor as high as capable of preventing a short circuit, because if the resistor is too low, there's a possibility of the current flowing to the ground, and we have to avoid that at any cost. So this is it. This is the pull-up resistor outside the microcontroller, and this will work for any microcontroller that doesn't support a built-in pull-up resistor. Good news. Our microcontroller, currently this Arduino Uno, supports the internal or built-in pull-up resistor. This means we can remove this pull-up resistor externally, and yeah, telling the microcontroller programmatically to enable the pull-up resistor inside, or built-in, the built-in pull-up resistor. And that will work for any microcontroller that supports pull-up resistor inside. Okay, so let's try and remove this pull-up resistor. I disconnected it, and I directly connect wire. I also have to remove this wire. No need of pulling to the VCC. So what I have here is the push button directly connected to pin number 2. Or we can just remove this wire and suppress the need of a breadboard and connect this wire directly to pin number 2. Before we change the program, see what has happened. Look very well at this LED. It's actually kind of blinking. It's unstable. I don't know if you can see it, but it's kind of blinking. And you can confirm this by checking this program. If you open the serial monitor, see what we are getting. You can see the values we are getting. Okay, let's try to stop. We are getting weird values. I didn't press a button, but see, we are getting 1 0 0 0 1 1 1 0 0 0 1 1 1 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 1 1 0 0 1 1 1 1. We are getting values, weird values. Remember, I am not pressing the push button, but we're getting 1 and we're getting 0. The button, the push button is currently erased, but we're sometimes getting 1, sometimes getting 0. It means this is unstable, and this is the state called floating. floating state is undesirable state, where the signal red on the pin is showing unusual behavior of the being high or low uncontrollably. And this is a state to avoid. See what happens when I press the button. See what happens when I press the button. The LED is stable now. Why? Because when I press the button, you know what happens. When I press the button, the pin goes directly to the ground, and according to the program, when I press the button, I'm supposed to have the LED high, and that needs to be high, and the value I print should be 1. So this is what happens. I mean, the value I get should be 0, because the push button now is directly connected to 0 and is pushed, and the pin has a signal 0. So this is what happens when I press the LED. I press the push button, the LED becomes fully on, because I have 1, but when I release, I have this instability. So when you have a microcontroller like Arduino that supports an internal PULLUP resistor, we don't need to bring back the LED. No, I mean the PULLUP resistor. We can just tell the microcontroller. You can just tell the microcontroller to enable the internal PULLUP resistor by simple to the input. You are in the setup method and this pin mode. You will change this pin mode to input PULLUP, and we'll upload this program, this new program. It's compiling the sketch. Taking a while. Working. Done compiling. Done uploading. Okay, so now let's see if it has worked. I press the button. Okay, before I press the button, you can see that the LED is not blinking in that weird manner. It's not blinking, it's off. I press, it's on. Much like what we had when we were using the external PULLUP resistor. Okay, so that's it. that was to explain to you the role of a pull-up resistor. So you may ask, is there in type of pull-up resistors? So that when you go to shop, you go asking, give me a pull-up resistor. No, any resistor, as long as it has a value as high as 10K, sometimes 4.7K will work. Yeah. So yeah, that's as simple as that. And if you don't have it, and you luckily have a microcontroller that supports a built-in pull-up resistance, you just enable that programmatically as we've seen it, and yeah, the job will be done. So thank you for your attention, and if you like this video, why not press the like button, and if you feel it can be helpful to someone else, why not sharing it? And if you think you will need to come here often and you need to be announced of the new video that I drop, you can subscribe so that you may be notified of any new video, because I'm here to stay. I'll be uploading videos about embedded systems, robotics, AI, any cutting edge technology. So if you need to be part of this community, please subscribe. And if you have a comment, why not comment down in the comment section? Why not comment, ask a question, request for a new topic, a new video. Well, have a nice day. Well, or if it's in the night, good night. See you in the next video. Bye.